Hi, so I just want to welcome everyone to yet another one of our WIT Tech Talks. So here at Mohawk College, the Women in Technology and Trades Group hosts a variety of activities on campus. And if you haven't seen some of our other symposium and Tech Talk programming, please check it out through our YouTube channel or by visiting www.mohawkcollege.com/WITT. And you can find out what other activities we have for outreach that you can get involved in. And today we have a fantastic talk from one of our amazing academic coordinators and faculty, Majlinda Qarri, who is responsible for our energy systems program here at Mohawk College campus. And she'll be talking a little bit about energy systems and renewables in her talk today. So welcome, Majlinda, and we're looking forward to hearing from you about how we can change the world.
Okay, that's great. Yeah.
If I could just ask, just ahead of things, just to keep the video running smoothly, if everyone could minimize their camera and mute their microphones during the presentation, I'd appreciate it. Thank you.
Yeah, and also I want to say, because as Liz explained before, my camera also sometimes makes my internet slow, so I'll turn off my camera as well while I'm talking. And I'm going to talk about renewable energy integration into the power grid. I want to thank you, Women in Technology and Trades, for this opportunity, and also for supporting me with some funding for the one of the courses that I've taken last year. So I'll talk a little bit about myself. I come from this beautiful country called Albania. This is where I was raised, I was educated, and this is where I finished my Bachelor of Electrical Engineering and also Master's in Electrical Engineering and my PhD as well. So I'm showing you these pictures just to see, and not to make any promotion about Albania, but it's really a beautiful place. And this is where actually is where my grandparents' house was, this village here. So before coming to Canada, I have been teaching for many years, for almost 13 years in university in the city of Albania, Vlora. So I was teaching in the Naval Engineering Department first, teaching courses such as AC, DC electricity, and electronics. But then we opened the Electrical and Computer Engineering Department, and I was part of that process, creating the full new curriculum for that department, for the Electrical and Computer Engineering, and then taught for a few years there courses such as process control and digital control, AC, DC electricity as well. And then when I moved to Canada with my family, I started teaching first at Humber College for a few years, and then in different colleges such as Sheridan College, George Brown College, and McMaster University as sessional faculty for a few years as well. And then I started teaching full-time at Mohawk College in 2013. And this is where my work, not only my teaching, of course, I'm very passionate about it, but also I've been working with IdeaWorks on different applied research projects at the Caroline substation that we own downtown Hamilton. And we have been working with my colleagues and also my students, such as John Margaritis and Zach, for example, here, and other students and technologists that we have been working on different industry-based projects. And also I've been supervising students for the applied research projects that we have done during the years when we had that applied research course, and I hope that comes back again because it was very, very exciting. So I've been supervising some of those projects as well, and I've learned a lot. Now, why am I interested in renewable energy and in a sustainable economy? I've taken two excerpts, one from a Canadian author and analyst, Naomi Klein, from one of her latest books, This Changes Everything, Capitalism versus the Climate, and where she says that slavery wasn't a crisis for British and American elites until abolitionism turned it into one. Racial discrimination wasn't a crisis until the civil rights movement turned it into one. Sex discrimination wasn't a crisis until feminism turned it into one. And of course, the continuation of this is climate crisis is not considered a crisis until we really turn it into one. And also there is an organization, 350.org, which I follow that, and I got this other part here from their main website, which is it's warming, so the planet is warming, it is us that is causing it, we are sure about that, it is really bad, but we can fix it. So you can see that it's kind of depressing at the beginning, but then there is hope in the end. We can fix it, we still have time to fix it. So I'm interested in the renewable energy and in a sustainable economy. And I'll share with you a very small story about my father. He passed away last year. He had this mentality that things need to be preserved and conserved. So always in the house, we had this rule that you have to turn off the light. When you don't need it, you have to shut down the water. When you are not using it, you have to take 5 minutes, for example, to take a shower, no more. So try to preserve the limited resources that we have. And this is something that actually I believe should be a mentality for everyone. And I know that it's not only up to one individual to make the change, but all of us as individuals should work to make a change. And if we all also come together, we can actually make a change. We can push and pressure our politicians to actually work towards a more sustainable economy. And the sustainable economy is based on not only renewable energy, but also in recovering and resiliency of the economy as well. So this is why I'm really interested and I'm really passionate about this stuff. And what I've done lately is I have taken last year a course and I got this, I got to be certified red screen expert in 2020. And then also with the help of my associate dean, Elizabeth Martin, which I want to thank you here for taking this course as part of my professional development, but also winning in technology and trade, which also helped finance this course that I took from the George Washington University on development and financing of renewable projects. So whatever I've learned by taking this course, I'll share with you today. Of course, not all of it, because that will take a lot of time, but I'll try to share some of the main things here. And then also I took another training course on Lead Green Associate, and this was in February of 2021. And again, this was as part of my professional development as well. Now, what is going to be covered in this presentation today will be renewable energy sources and unique features of these renewable sources. I'll go over energy global market overview and how the renewables have entered this market and what is their place in this global energy market. And then over some steps on project development process for the renewable projects and some of the regulatory framework. So before I start with renewables and their unique features, I'll try to go over quickly over the one-way conventional or traditional way of powering the grid and powering our homes, commercial and industrial plants as well. So how the energy flows is it starts from a generation power plant, and that can be of different type of power plant. And then it goes to a transformer where the voltage is stepped up into very high levels in order to be transmitted through these transmission lines. And the reason for that is to reduce the losses, and also that makes sure that the size of the cables of the transmission lines are reduced, which in this case also reduces the losses of energy. So this is why the transformer is used to step up the voltage produced by the generation into transmission line voltage level. Then this goes usually to transmission substations, and there might be different steps of making the voltage now down from the very high level voltage into a smaller level voltage, which will go into the distribution lines and into a distribution substation where another transformer will step down the voltage from this level to a smaller level, like the level that will go into the consumers. And here is where it actually it is sent into other smaller transformers that will take this voltage into our homes and make it to 120 volts, which is or 240 volts for some appliances. But that's the nominal voltage that we use in our houses. But from the distribution substations, we will have also other lines that go into the commercial, which will have another voltage level. For example, might be 600 volts, 347 volts, and some other feeders that will go into the industrial plants, which might be into higher level of voltages, depending on the equipment that this transformer is feeding. Now, with the introduction of introducing of the renewables, but not only renewables, of other, like for example, when we have isolated microgrids that are out of the main power grid, the power grid in general becomes much more complicated. So this, now we don't have just one way conventional flowing of the energy from the generation power plant into the load or consumers, but we will have different parts of this of other sources. Like for example, you will have in this cycle these solar panels, which are a source of energy, wind farms, which are another source of energy, and that can be combined with conventional power plants as well. And you'll still have the transmission substation, the distribution substation, and we might have, for example, electrical vehicles which need plugging into the power grid as well. You might have solar power charging stations for electrical vehicles and so on. So the grid, as you can see here, becomes much more complicated. Now, what are I'm going to talk a little bit about the different types of renewable energies, and I explain a little bit each one of them, but not too much in detail. So the first one is the solar energy, and then we have wind, hydroelectricity, which is produced from water. We have the bioenergy, which is basically biomass and biofuels. So it depends. This one is actually divided into two main parts. One is the traditional one, which uses also the charcoal and wood. The other one is biofuel, uses liquid biofuels produced by plants with a certain process of treating the plants and creating this liquid biofuel, but also other technologies that use the bioenergy. And then the geothermal one, solar, wind, hydro, and geothermal, and the hydrogen. I'm going to explain in the next slide a little bit more. So solar panels, or the solar energy, is used to actually take the energy from the sunlight, and these are photons hitting these semiconductor materials, which are the photovoltaic cells. And usually this semiconductor material is silicon, and it frees electrons that, because they are connected into an outer circuit, it creates this electricity flow. But because this energy created is a DC energy, electrical energy, then you need to have inverters that will convert or change this energy from the DC type energy into AC, that can be going back to the grid or feed the your loads in the house. For example, when it's residential, but it might not be only residential, can be used for commercial, can be used for industrial equipment as well. The next one is the wind. So wind energy, we usually use wind turbines, but there might be wind tunnels as well that will actually take this energy from the wind, which is used to rotate the blades, as you can see here, of a wind turbine. And in the upper part of the wind turbine, you find usually a generator, and the generator will take this mechanical energy created by the rotation of the blades, which are connected into a shaft, and convert that into electrical energy. And this electrical energy through cables is transferred into a transformer, which will step up the voltage from the level that is produced into levels that are adaptable to the grid where this power is going. Or if this wind, for example, if it's a small size and is used for one house or a few houses, then it will go directly to feed the load into these houses. The other one is, and this is the oldest one, actually technology used, is the hydropower plant. And we have a lot of this in Canada, and it's actually the major part of the renewable energy in Canada is from the hydropower plants. So what is used here is, through the dams is created, we have this difference in height between the lower part of the water, so where the water is contained, for example, river water, and then we have a reservoir which is created by man, of course, and this reservoir is where the water will stay in this high level until it is needed. So when you need energy, electrical energy production, then the gates here are open, which allows the flow of water, and that the water pressure turns around the turbine here, which on its turn, we have a generator here that will take this mechanical energy again and convert it into electrical energy. And then usually we have a powerhouse in there, which contains a transformer that will take this energy, electrical energy with a certain voltage, produced with a certain voltage, and step up the voltage again into the transmission line level voltage. The other one is hydrogen. So the hydrogen, which is recently, not very recently, but it's still an emerging technology, and it's still in its beginning of being used in transportation and also in especially in utility or power scale. So how the hydrogen works, the fuel cells work like batteries, but they do not run down or they don't need any recharging. They produce electricity and heat as a byproduct as long as fuel is supplied. A fuel cell consists of two electrodes, a negative one and a positive one, which they are sandwiched together around an electrolyte. So a fuel, for example, such as hydrogen, is fed into the negative electrode and the air is fed to the other one, which is called cathode. In a hydrogen fuel cell, a catalyst at the anode separates hydrogen molecules into protons and electrons, and they take different paths to the cathode. The electrons will go through an external circuit, creating a flow of electricity, and the protons will migrate through the electrolyte into the cathode, where they will unite with oxygen and the electrons to produce water and heat. So this is the main principle of the hydrogen fuel cells. We also have geothermal energy, and the geothermal, how it works, actually cool water is injected into the ground, into the earth, and hot water is pumped back up and produces heat, which is used to produce steam, and steam is used to turn turbines, generator, and produce electricity. However, for electricity generation, high or medium temperature resources are needed, which are usually located close to tectonically active regions. And this kind of renewable resource actually covers a significant share of electricity demand in countries like, for example, Iceland, that's the first one, El Salvador, New Zealand, Kenya, and Philippines, and also covers more than 90% of heating demand in Iceland. The main advantages of this one are that it doesn't depend on the weather condition. And for this reason, geothermal power plants are capable of supplying base load electricity and as well as providing ancillary or auxiliary services for short and long-term flexibility in some cases. Also, we have, I haven't shown it here, but ocean, for example, wave energy, which is taken by converters. So the energy of the waves is captured and it's used to generate electricity, or tidal energy, which is produced by either tidal range technologies to harvest power between high and low tide, but there are other technologies as well. Now, all these are also emerging type technologies. Now, an example of the hydrogen use, for example, is in a village in south of France. They are blending the hydrogen produced by using electrolysis from solar and wind energy. So they have solar farms and wind farms, and they take this solar and wind energy and blend it, and by using an electrolysis, they produce hydrogen, which is then blended into the gas pipes, and that reduces the carbon emission from the natural gas usage. So this is shows you in this is so what is called the solar park in France, and it's a lot of solar arrays, of course, which contain a lot of small photovoltaic cells. And then the other one is in Dubai. Also, we have here one of the largest wind farms, and that's located it's an offshore wind farm, which is built into the ocean far from the shore, and that's in England, is the biggest one, largest one, but there are a lot of other offshore wind farms. Okay, so I'm going to move actually over to this one, and I found this very interesting while I was doing some research. This is this is not yet in place, but this is the first hub and spoke energy scheme, which will involve building an artificial island 80 kilometers out of sea and this is from the Danish Energy Agency, so it's in Denmark. Denmark was the first one to build actually the first offshore wind farm in 1991. And now they have agreed to this ambitious plan for another global first. So they will build an energy island in the North Sea, which could eventually be capable of supplying energy to almost 10 million homes. And this will boost significantly the production of wind energy in the world. And it will, for the initial phase, they actually are planning to produce about 3 gigawatts of electricity, but the plan is to scale it up to 10 gigawatts, which is nearly 1.5 times Denmark's current electricity needs, which means not only they will cover their own electricity needs, but they will also give this energy to other European countries. So this island, it will house batteries for energy storage so that it can cope with periods of excess demand. And they say, the Danish Energy Agency said that its long-term ambition would be to use the renewable energy generated to produce green hydrogen fuel, which can be transported to the mainland to power vehicles and industry. So also to power with hydrogen created from the wind farm here, also to power transport as well, which is great. So now we're going to go over the some of the unique features of renewables and how that has interrupted the power grid, and what are the measures that are taken actually. So if we look at this graph here, it will give us a typical residential household which uses in 24 hours approximately 40 kilowatt hour per day. So we will have the household is the blue one that shows how much and how the energy is distributed. Actually, the demand is distributed in hours. So starting from 12 a.m., let's say, and then going up to 12 a.m. or 11 p.m. here. So the solar on the other side is the one, in the graph is the line showing in brown, color. So that will show you that we of course have no solar output up to when the sun starts rising, and then of course it starts rising and its peak is about 12 p.m. so in the middle of the day, and then it starts dropping again. But this peak, and this is a problem, is that this peak, the solar peak, does not match with the household, let's say, or residential peak, of course. And in places where there is a lot of sun, like in California, for example, when they have a lot of solar panels, so they get a lot of solar energy, they have an excess of solar energy. And if you don't have any storages available to store this energy, then this solar energy goes to waste. So in these places, and again, this is especially in places where there is a lot of sun, is created this phenomenon called the California duck curve. And as you can see here, the part is where, and it's going always down, is the part where the load actually here goes down because people are not at home, so they're not using a lot of electricity. And then when people go home, like after usually 4 or 5 p.m., then it starts increasing, the demand starts increasing, but the solar energy is not there anymore. So this is known as the California duck curve, and the California Independent System Operator has been monitoring and analyzing the duck curve and the future expectations for a long time now. So according to their last study, the US Energy Information Administration found that the wholesale energy market prices over, let's say, the past 6 months last year, during 5 p.m. to 8 p.m. period, have increased to $60 per megawatt hour compared to about $35 per megawatt hour in the same time frame in 2016. And this is exactly because of this duck curve here. So again, there are the only way to keep this, to have this solar not go to waste, is using the energy storage. So that is very important. So what this creates, and not only for the solar, but also for wind, and I'll show you another graph here, is that the wind power plant, for example, can drop down from a very high output into a very small output, and then can drop down to zero. But this is, you can see here from this point to this point, within minutes, it can drop down almost 44 megawatts per minute. So it's a very high drop, and that somehow needs to be compensated. So what happens with the wind and solar energy is that they are great. We introduce them into the power grid, but they also are intermittent in nature, which means that you can have a drop of wind, which will have a drop of the output from the wind turbine, so from the wind energy. So what does that mean? It means that the grid operators, or the organizations like such as, for example, IESO, which is the Independent Electrical Systems Operator in Canada, or ISO, Independent System Operator in US. So they have to make sure that they have another plant ready there. So many times what happens is with the building of the solar, for example, farms, or the wind farms, but especially with solar farms, you might have nearby a natural gas plant, which will be very flexible to be put into the grid back if something happens. For example, if you have sun, but the sun goes out because you have clouds coming in, or if the wind drops, like in case of the wind farms, when you have wind energy use from the renewable. So these are things that actually interrupt the energy, and also interrupt the grid, and create problems into the power grid, and especially create problems for those organizations such as IESO and ISO that need to balance the demand with the generation. So in order to kind of something that helps is, again, it's storage is one thing. The other thing is weather forecast. So sometimes in order for the renewable energy, like for example, the solar and wind, to participate into the energy market, it's good to have like very good prediction of weather. So are we going to have wind the next day? Are we going to have clouds the next day, and so on? So that will help solve some of these problems. But again, the main thing is, and I was talking about this, is need for having some backup, some reserve margin when your renewable energy is not there. And also the last one is the increased need for storage, batteries, and flexible power generation, like for example, natural gas and diesel generation. So these graphs will show you increase in reserve requirement, and this is in percentage based on different countries. For different countries is different based on what kind of backup reserve they have and how much that has to be increased in terms of how much renewable energy, wind or solar, they have introduced into their power grid. So again, this percentage is different in different countries. So that will show how much increase in reserve requirement is needed. For example, for Finland, you'll see here it's gone from 10% of 15% of the wind penetration. You'll have from 4% to more than 7% of the increase in reserve requirement. And also this costs, increasing balancing costs as well. And again, this will depend in different countries and different companies that use to balance the load and demand and the generation in each country. So impacts of renewables penetration on the power grid is, we'll see here, if it's less than 5 to 10% market penetration, then there are no major issues in the power grid. If it's between 10 to 15% market penetration, then there are noticeable impacts on the power grid, on the transmission lines. And also if it's higher than 15%, need for comprehensive assessment of power system design and operation. So it needs to be reassessed, the power system and the power grid in the way it is, and need to be an analysis, economic analysis need to be done in order to see if this increase in the renewable energy, it's really helping the energy, the power energy, the company, the country to actually fulfill not only their carbon footprint, which is of course one of the main outcomes of using renewable energy, but also to see economically if this is a viable solution for them as well. So energy storage is, as you can see here, it might be introduced in different parts of the power supply chain. So we can have consumer side storage, which can be, so we can have some storage here, which is small size storage. And also this is known as behind the meter storage. So it's always important to store energy when there is surplus and use it when there is high demand. And the other place is between distribution and transmission as well. So this storage usually is used, for example, battery, utility scale batteries in substations to provide ancillary or auxiliary services and reduce congestion. And then we have on the generation side, storage is installed close to power generation, such as, for example, wind and solar plants. When we look at the energy storage, we need to look at the amount of time is needed and the period of time that this needs to be used to determine which type of energy storage is suitable for the application. So there are different types of energy storage technologies. There is a lot of them, and they will change based on how much they can store, so the capacity, and for how long they can store it. And as you can see here in this graph, You can have, for example, UPS power quality. It is maximum up to 100 kilowatts, but it can store energy for hours. We have also, like, for example, pumped hydro can store very high energy and also for hours as well. There are new technology, like, for example, the energy such as the one with the heat, which is gathered with salt containers, and those sand containers, sorry, which keep the heat for a long time, and they are usually seasonal or also years. So different types of batteries will be used depending on the application, and depending on if you don't want too much energy stored, but you want it for a long time, or you want too much energy stored for a short time or for a long time. So depending on what the application is. But the types mainly are categorized into different types of batteries, with one of them being kind of the most avant-garde, which is the lithium-ion battery, the ones also used for Tesla, for the electrical cars. And also now they have utility scale lithium-ion batteries, also as well used in the substations. So there are thermal ones, mechanical, like, for example, high power flywheels. We have the hydrogen ones as well, and the pumped hydropower. So these are some examples of the these are the concentrated heat sands, and this is used when there is sun. It takes the heat, and the sand contains this heat for a long time, and then it's released when it's needed through pipes, and it's converted into steam, so steam turbines can produce energy. And then in the other image here, you see in a substation, we have all these lithium-ion type batteries that are used to store energy. And this is the energy storage of the future. So where we have solar panels and wind turbines that can be used, as I mentioned earlier, can be used through an electrolysis process to create hydrogen, to produce hydrogen, and then this hydrogen can be stored into this hydrogen energy storage. So this one, and I'm hoping that this will be the future actually, because hydrogen can enable 100% or near 100% renewable power grid. Now the mass deployment of storage will be actually one of the biggest overcome of using and integration of the renewable energy. Okay, so let's go over the global market overview. And so the key energy resources, what are these key energy resources that we use is as shown here in this image, which is taken from the International Energy Agency. So we'll see that, of course, one of the most abundant energies that we have and we can use is the solar energy. And then there is hydro, wind, uranium, coal, gas, oil, but especially the upper part here, this is not a good energy because it creates a lot of carbon footprint, and we want to reduce this carbon footprint. So according to the Renewable 2019 global report, renewable energy is expanding in the power sector with 181 gigawatts newly installed in 2018. So the rate of new capacity additions, actually the last 2 years has leveled off a little bit, especially in developed countries, but it looks like it's going up in developing countries. So the global renewable power capacity grew to around 2,378 gigawatts in 2018 only. Now, here if you see in this slide, there is this is for US example, but might be similar in other countries as well. There is the relation between energy consumption by source and by sector. And this is taken, is a report from 2017. So we can see that in percentage, the petroleum actually it is 37%, and then you can see that it's divided and it contributes actually in all sectors, in transportation, in the industrial sector, residential, commercial, and the electrical power. And the electrical power sector is actually an intermediate sector that is used also to feed other like transportation, industrial, and residential commercial sectors. Natural gas, it's 29% and also contributes in all of them in transportation, industrial, commercial, residential, commercial, and electrical power. And then we have coal, 14%. So coal does not contribute to transportation, but contributes to industrial, residential, commercial, and electrical power. And then we have renewable energy, which contributes to all four of them, with nuclear power, which only contributes to the electrical power. The estimated renewable energy share of total energy consumption, and this is a report based on OECD. OECD is an economic organization which is based off so far 37 countries, and also the IEA, which is the International Energy Agency. So we can see here roughly what is the renewable energy share in the total energy market. Of course, the most one in global market, energy global market, is the fossil fuels, which is almost 80%. We have the nuclear energy at 2.2%, traditional biomass at 7.5%, and then renewables at 10.6%. And here is a subdivision of the renewables into modern renewables like wind, solar, biomass, geothermal, ocean power at 2%, 1% biofuels for transport. Then we have hydropower at 3.6%, and biomass, solar, geothermal, heat at 4.2%. So this has increased based on the reports from other years, from previous years, and it continues to increase more. But again, when it comes to the energy and the power grid, the grid operators, they come into this trade-off. So do you want to increase more and to have more renewable energy, but on the other side you want also to have this flexibility of other sources, or to have that increased reserve margin in case when the renewable energy is not there. So on Canadian market, we have a share of energy supply from renewable sources. And this shows here what is the renewable share for the whole world is about 13.4%, in OECD countries 10.5%, and in Canada is higher, 16.3%, but that is because of the hydro energy that we are using. And as you can see here, the Canadian renewable energy electricity generating capacity, most of it comes from the hydro. Then we have wind and tidal, solar, and biomass. Now, this will show you in terms of years starting from 2001 to 2017, additions of power generating plants. And on this side, we will have the additions in gigawatts. So, and we will see that solar and wind actually dominate the electricity generation capacity additions starting again from 2001 to 2017. And in this slide, you will see that investments in renewables globally, they have shifted actually starting from 2004 to 2017 from developed countries to developing countries. And the numbers here are in billions of dollars. So how much investment in renewable energy we have in developed countries and in developing countries in years. So what are the key trends globally? We have, as the technology progresses, of course, there are reduced cost of renewables. We have moved to more competitive tenders because of the cost of renewables have gone down. So that means that they can now compete better and fairly with other types of energy. And also there are some climate mitigation strategies taken by many countries in the world. So many countries, they have decided and they agreed upon to reduce their carbon footprint, and especially European Union, but also America and Canada as well. So we have these strategies that are actually driven by the government to reduce carbon footprint, and one of them is, of course, increasing the usage of renewable energy. So this graph will show you the cost, the declining cost of wind and solar, which is, as you can see here, for example, the price of solar is actually going down a lot from 2009 to 2017 because of the development in the solar technology. And then also we have wind, onshore and offshore wind also declining. So the offshore wind has gone up for a little bit of time and then also gone down again. Now the last part of this presentation is on project development process. So the development of renewable energy projects has attracted more and more as time goes by, more entities such as utilities, power companies, energy companies, governments, colleges, universities, landowners, energy consumers, etc. So all these stakeholders, they recognize the economic, environmental, and security potential of renewable energy. Project development is primarily viewed as an entrepreneurial activity, which is subject to significant risks and unknowns while requiring always ongoing investments of time, financial investment, and also political resources towards an output that consists of a completed project. Now, according to National Renewable Energy Laboratory, there are two main concepts that need to be developed for a renewable project. One is the project motivation. So a project motivation is based on a motivated project, which is one that has a strong basis to come to completion and is built on economics and risks that are acceptable to all parties involved. Is based on supportive policies from governments and also project bankability. So how, which means how this will be profitable. The second concept, based again on National Renewable Energy Laboratory, is developing a contextual framework and mapping an established, repeatable, disciplined process for project development that is consistent with professional industry standards and practices. Now we can summarize the process of project development for the renewables into 5 phases. Phase 1 is concept development. Phase 2 is pre-feasibility study. Phase 3 is feasibility study. Phase 4, permits, finances, and contracting. And the last phase, or phase 5, is engineering, construction, and operation. So for phase 1, the first one is identifying the sites. What are the things that need to be taken into account when you buy a land to develop a renewable project? So things to be considered are climate. For example, if you are going to build a wind farm, is this a good place or a good land where you have a lot of wind so you can use the wind farm? If you are building a solar farm, then is this a good place to get sun most of the time, and so on. So the climate is important, the topography of the land is important, accessibility of the land. So are there roads nearby, for example, or you need to open new roads, which will cost more? distance from the power grid. So also that matters because usually it's the owner or the developer who will pay for that extra transmission grid or the lines that are going to connect from this new power plant into the existing power grid. What are the power grid connection and regulations? What are the land user regulations, which also change from country to country? What are the environmental impacts and also social impacts? For example, if you have noisy wind farms, for example, close to populated areas, or impact on species at risk, and also financial incentives, which depend on the country. So the second one is the project concept. What type of technology is going to be used? Solar, wind, or any other type of renewable technology. Is this technology new? So, or is this technology something that there is experience from before? What are the potential off-takers? So identify the grid operator in the area and see what if they are going to buy the electricity that you are going to sell or produce, and at what price they are going to buy, what regulations are in this case, and also, like, you need to create a business case, and the business case means that you need to know roughly what will be the size of this project in terms of how much energy will be produced in megawatts. And the whole project development process is led by developer or sponsor, also known as the owner. He or she contributes funding for the early development part of the project. So is this person who drives the project forward? Is this person who takes the risks? And also by the time that feasibility study is done, which is phase 3, based on the size of the project, between $2 to $5 million might have been spent. So having also support and incentives from the government is it helps. Phase 2 now is the phase where pre-feasibility study is carried out, and during this phase an assessment of the different technical options are evaluated, the costs related to the project are evaluated, how much electricity will be produced and sold, what are the permits that needs to be taken, licenses, etc. So identification of the site and the available area to install solar panels, for example, or wind turbines, etc. Conceptual design of the power plant with the anticipation of investment requirements. Then the pre-feasibility study may recommend that wind measurements, for example, are required for 1 year or more according to industry standards. So pre-assessment of the environmental and social impacts as well are done. So for example, when building a wind farm, we must take into consideration if any migration bird path is on the way, or solar farm, see if there are animals in extinction living in that land, etc. So there are other things that has to be taken into account, like, for example, what are the anticipated costs and what is the profit roughly, and then the financial model using softwares, for example, and then the grid connection and assessment of regulatory environment. Phase 3 builds on work done on phase 2. So this is the feasibility study phase, and that repeats the analysis again from phase 2, but goes much more in detail. It confirms the financial viability of the project. It recommends a roadmap for the project implementation, includes contracting strategies and financing approach. It also prepares design specifications and the request for proposal, which the developer can use to choose contractors and suppliers to build the power plant. So depending on the developer's sponsor, he or she might contract the operation and maintenance of the plant to a company when the project is completed, but that's up to them. There are cases where the owner or developer, depending on how much time and energy they want to spend on this project in terms of after the project is completed, do they want to operate by themselves or do they want to transfer this into a third-party company? Or sometimes depends on how much knowledge do they have, how much the experience they have with other projects as well. So sometimes the later, which is contracting the operation and maintenance of the plant to a company, might be required by the insurance company and the financiers of the project as well. Now, the next phase, which is phase 4, phase 4 is a time where financial commitments start increasing significantly. Land needs to be secured by now. So that needs to be secured either by a leasing agreement or by purchasing the land. Building permits and licenses need to be secured. Environmental permits may be required, but that depends on the country. It is recommended to have consultations with all stakeholders, starting from phase 1 on this. And then grid connection agreement needs to be secured and the preliminary energy purchase agreement needs to be drafted with the off-taker or the grid operator in the area. Environmental and social considerations also need to be taken into account. So, for example, a sensitive flora and fauna, archaeological and historical sites might be also considered, and local financial institution requirements for loaning purposes. So not all countries or not all places have the same requirements from the local financial institution, from banks. Also during phase 4, there is a layout design need to be done. So all the drawings of the area, the civil design, topography design, the electrical detail design, and also revised energy yield. So sometimes even when, for example, if you have a wind farm, you might leave the completed project for a year to gather data so that you can see that this is not only profitable, is efficient as well. So also construction plans, scheduling and commissioning plans as well. So consideration sometimes must be given to site specifications in terms of soil, snow and cleaning regime as indicated by the operation and maintenance contract. Now the key contracts that are used are the power purchase agreement, which is known as PPA, or electricity power agreement. This is a contract between the two parties. One is the seller, so the developer or the owner who develops this renewable project, and the buyer, which is the one that purchases the electricity, so the grid operator in the area. The PPA defines all the commercial terms for the sale of electricity between the two parties, which includes when the project will begin commercial operation, the schedule for delivery of electricity, any penalties if there is any under delivery, payment terms, and also termination terms as well. So the PPA is actually the principal agreement that defines the revenue and the credit quality of a generating project. And so it's very important, or it is a key instrument of the project finance. Now, the term of a PPA usually may be between 5 or more years. And a PPA is usually legally binding once it has been executed by the seller and the purchaser, but might be subject to early termination rights depending on the cause. So also we have a grid connection agreement. So the project developer needs to have an agreement with the grid operator for the grid connection, and usually the owner or developer of the project is responsible for the lines that connect the new power plant to the existing power grid, but then the maintenance of this is done by the grid operator later. Also construction contracts, and these are contracts that will be done by the developer with, for example, an engineering contracting company that will take care of everything, or with different multiple construction trades, if the owner is leading this construction phase by him or herself. So in that case, in the later one, the owner is the one who is responsible for making sure that any conflicts are resolved, the scheduling is on time, they are on budget, etc. But if this is transferred with a contract to an engineering company, then it's the responsibility of the engineering company to do that. And the last one is the operation and maintenance contract, which is the contract that is done, again, in case that the owner or developer wants to transfer the operation and the maintenance of the power plant after it is completed to a third-party company. So the last phase, or phase 5, is the construction. So this is where the construction starts. And again, the EPC, or the engineering company, or the owner, depending on how this thing is done, will be responsible for the construction phase and for completing the project on time and on budget. The commissioning phase is done with 2 types of tests before, for example, before the engineering company gives this completed project to the owner, or before the owner makes the connection to the power grid. So one of them is the acceptance test, where the completed project has a desired outcome, and it's based on industry standards, and it meets the specifications required, and the power generated is according to the industry standards, and the plant is ready to operate. Now, also sometimes might be that a reliability test is required, which means that the power plant might be put under working conditions for a certain amount of time to observe how it operates and the efficiency before the owner takes it from the engineering contracting company, or before it is ready to be connected to the main grid. And then, of course, it's the operation starts. So financing as part of the development process is usually the owner at the beginning is the one, or the developer is the one who takes all the risks, and it starts phase 1 and phase 2 before it goes to phase 3, which is the feasibility study. But when it comes to this phase, and after the feasibility study is done, the owner might have spent between $2 to $5 million, depending on the size of the project. So then if they don't have the amount of money to go on with the project, they can ask other investors, they can ask for bank loans. And also, after the main challenges and the risks have been removed, or the main risks have been removed, then they can ask for refinancing of the project. Sometimes there are governments that can help, and this was before, for example, there were grants, especially when the renewable energy was at the beginning phase. But now that this technology has becoming more and more and has been introduced more into the power grid, then grants are not used anymore, especially in developed countries. They might be still used in the developing countries. So there are some regulatory framework that support actually support the renewables and the renewable installation, and in every country is different. But what we can see from this graph here is the number of countries with renewable energy regulatory policies and carbon pricing policies. So we can see that there are 20 countries that apply some rules, and they have some energy regulatory for heating and cooling, and then 44 countries that apply carbon pricing policies, 70 countries that apply transport regulatory policies, and 135 countries with power regulatory policies. Why the need for regulatory support? It's because the cost of renewable energy sources. So we want to make sure that that the renewable energy sources, they can compete fairly in the energy power market, sorry. And then we have sometimes pushback from the stakeholders. So this is why there is need for regulatory support and regulatory framework. And also sometimes there is no monetary incentives. Now, targets, regulations, public financing, and fiscal incentives supporting renewable energy development and deployment are found at the international, regional, national, and subnational levels. At each level, policymakers have the opportunity to design a mix of support policies which are tailored to their respective jurisdictions. So these regulatory policies, which include, for example, feed-in policies and renewable portfolio obligations and also green certificates, these are policies that have been used before, and they continue to, in some countries, it's still continuing to be used. The feed-in tariff, for example, is a mechanism which is designed to accelerate investment in renewable technologies. This was first introduced in Germany, and this offers long-term contracts to renewable energy producers, sometimes between 15 to 25 years. So the goal is to offer cost-based compensation to renewable energy producers. So these feed-in tariffs, they award different prices to different sources of renewable energy in order to encourage development of one technology over another. So the payments per kilowatt hour are differentiated by the type of technology, by the size of the project, project location, and the quality. With these contracts, the owners or developers are guaranteed access to the power grid. Also, another method is the green, or another regulatory support mechanism is the green certificate, which is a tradable asset that provides electricity, that proves that, that electricity has been generated by a renewable energy source. So this is a market-based instrument that represents the property rights to the environmental, social, and other non-power attributes of renewable electricity generation. They are declining as renewables are becoming less and less expensive. Renewable portfolio obligations, which are mainly used in US and UK, it's an obligation portfolio set by the government on the power companies to produce a percentage of their electricity from renewables. This percentage may be constant over the years or might vary, again, depending on, depends on the state or on the country. Now, during the last years, the tendency is going towards competition, auction, tenders. So the objective of the auction is to procure renewable capacity, and instead of government intervention here, so this is the renewables now compete into private market, energy market, as all the other sources of energy. Now, this graph will show you the utility scale capacity growth, which shows in terms of years how much energy in gigawatts is used by the support of administratively set, so which means government set prices, or competitively set prices, which is the yellow one. So you can see that as we come from 2012 to 2018 or 2023, so the renewables will be more, will take more part into the competing auction tender. So the feed-in tariff in Ontario, this program was introduced in 2009 by IESO, and that made sure that energy generators of renewable energy were offered a guaranteed price per kilowatt hour, that of course depending on the type of technology used. Contracts were secured for 20 years, except for the hydroelectric power, which is 40 years. And also microfeed program was offered for capacity of renewable energy less than 10 kilowatts, also with a 20 years contract. But it ceased in 2016, and ISO stopped accepting applications under this program. Now, at Mohawk College, we have the JCPI building, which is building net zero building, and it's using renewable energy to feed the electrical needs or demand of the building. So it's we have a lot of solar arrays on the roof, and also the envelope of the building is very airtight, so it does not allow for a lot of heat or energy to go in and out. So that means that it will use the energy used during the amount of time is less than in a normal building with a normal envelope. So the envelope here is very good, so it does not allow that heat exchange between the external and internal. And also we are using geothermal in this building, which I explained earlier. So that's for heating and cooling. Now, renewable energy in the Power Lab, we have this energy program, and we are using actually in a few courses, the solar panels technology is taught to students, and then also the wind tunnels and the wind energy technology is as well taught to the students. And also lately, the last few years, we have got this fuel and the hydrogen fuel cell energy here, which is the technology which gives the opportunity to students to see and experiment with the hydrogen fuel cell technology. Also, there are projects that have been done, as I mentioned earlier, with the with industry, and this is an example of a wind tunnel that is done for one energy customer. He wanted to build a new wind tunnel, and one of our students was working with this person, which was an owner or developer of the wind tunnel, and this is a new technology used for the wind tunnel here. Oops, sorry. So these are the references that I've used for my presentation here today, and thank you. Any questions?
So I just want to jump in here and say thank you, Majlinda, for giving us a very comprehensive look at how this industry is structured. Are there any questions from the attendees? I have a few questions, but I don't want to jump in until we make sure that the audience has had a chance to participate. Are there any questions from the audience? Maybe I'll ask my, oh,
I don't have a question. I just wanted to say that was a really fantastic lecture, Majlinda. Really,
thank you.
Yeah, very much. Thank you.
So I have a couple of things I'll ask just to kind of seed the conversation a little bit. So listening to the overall talk, I'm thinking about, what are the ways that a student who's interested in getting involved in the energy sector can do that? And obviously, if someone has a comprehensive interest, we would love to have them join us for our program at Mohawk College and the 360 program that Majlinda is coordinating. But there are a variety of other ways that I think there's a lot of overlap in the sector. So I just am kind of looking to bounce this off you, Majlinda, because one of the things that we like to do in these sessions is identify for students the different ways that they can get engaged in this kind of activity. So I'm thinking, from the emerging tech perspective, we've got all these new types of science that are coming in to develop the next wave of renewable energy resources. But in addition to that, you talked a little bit about building and construction and how everyone within their capacity, whether it's architectures or building planners or civil engineers, are engaged in developing new buildings, or electrical engineers in their responsibilities working in power plant now have a completely different set of resources that they need to become familiar with. From an energy perspective and what we teach in the program, the idea of energy auditing, the idea of trying to decide what kind of energy is best for me and how do I optimize for peak usage,
Exactly. Yeah.
Yeah. And then I'm thinking on the non-traditional side of things outside of science, also just thinking from a finance and banking perspective, you mentioned how much of this relies on the banking industry and also on government policies and some of the maybe slightly less traditional things when you start thinking about energy, but there would be different ways that someone who was interested could get involved in making a real meaningful difference in getting renewables adopted. Um, and the other one that I heard you say a couple of different ways is maybe data analytics and just the importance of being able to monitor where we're using our energy and then adjust things so that we can make a better use of it. Did I miss anything or?
No, you summarized it very well.
Okay. I guess, the take home message, if there ever was one, is that this is going to hit every industry. That's the way that I'm thinking about this.
This is the future. This is the future. Yeah.
Yeah.
And the buzzword now in the renewables is energy storage. That's yeah.
Yeah, energy storage and not waste, right? I think so. So if I dial it back then to what we can do as individuals walking away from the session, there were a few things I heard you say, and if I missed anything, again, I'd love for you to jump in and add. But you mentioned, the idea that peak usage and just being very aware of when we consume our energy and how we consume our energy can make a huge difference. And you said, that to the extent that energy window between 4 and 9 p.m. where we're all at home eating dinner and we're all kind of heavy users, if there are things we can do or defer to kind of avoid that duck scenario, that actually helps us from needing as much capacity in our whole energy grid. So that was one thing that I kind of was a new piece of information for me. And the other thing that you mentioned, where I'm just thinking about areas where we get to make choices as consumers. I know recently I put in like an intelligence agent in my house, one of those Alexa add-ons, basically, that will monitor my energy and started getting very opinionated about telling me how to save energy. So I don't know if others have done that so far, but my experience has been I've started to see the cost of my energy go down. So it's been pretty incredible to watch and to see things change and evolve over even the last few years to a place where, we really can start to make a meaningful impact on the amount of energy that we're using as a consumer.
Yeah, that's true. That's true. Yes. In our house, for example, and I'm lucky, my husband, he's an electrical contractor. So he changed all of our lights into LED lights all around the house. So that has brought our bill, electricity bill down a lot. And also we have in most of the bathrooms, we have the motion sensor. So you go there, light turns on, and then light turns on, turns off after, right? So, and stuff like that. But also we have the smart thermostat as well for the heat.
Mm-hmm. Yep, and it all starts to add up, doesn't it?
But not the Alexa yet.
Oh, not the Alexa. Well, that's me being lazy, I guess, or just trying to avoid scaring my cat. So I really want to thank you, Majlinda. One of the things that, we've heard over and over again from our students is we're looking for ways that we can make a difference. And so hearing about all the different opportunities here, as well as hearing about some of the practical things that we can start doing to make a difference and start, as you mentioned at the very beginning, start to be part of that change and making everyone aware of how important this is. And
yes,
and again, sometimes it takes a little bit of a while for industries to catch up with the need. And it does feel like in this field, we're still finding a place for the roles and for the needs of this industry. And so the one thing that I would like to say, if there are kind of any high schools that are trying to figure out how to integrate this into their curriculum, or on the receiving end of things, if there are companies that are starting to explore those options, we do have the Epic Center at Mohawk College, and we'd certainly welcome the opportunity to talk about project work, or, you know, to talk to you about what you can do to start getting into the energy auditing side of things in your business. And I know $2 to $3 million can seem like a monstrous prospect, but if you think about the cost of putting a new power system in, or power grid in, we're talking somewhere on the order of $1 to $2 billion sometimes. So it's certainly a big project.
Yeah,
but,
it is.
But the payoff, if you think about it in terms of the overall project costs that go into putting in some of these energy resources, is pretty remarkable. So I just wanted to kind of say that because I think sometimes you'll hear that price tag and you'll go, oh, what's my role in this? But when you think about how big these energy projects are and how costly they are to maintain, to your point, it really is where we're going, isn't it?
It is, yeah. I think this is where the future, and we should be optimistic about it. But in order for us to be optimistic, we should also do our part, each one of us individual. Even if it's a small, it always makes an impact. And the thing is, I have a saying, which is not mine, actually. It's it's from Albania, but it says, we can build a wall one brick at a time. So you need individual actions, as well as also government action as well, right? Or private companies to enter into this. But I see that private companies also, they have begun actually to take more and more into this, because they see that it's a profitable business, right?
Mm-hmm. And I guess the other piece of it, just in the interest of, you know, where we are in Canada, is just the importance, as you mentioned, the fact that we just can't turn off traditional energy and move 100% to renewables. And there really is a place for this balance and mixture as part of the conversation. And certainly we want to move more to renewables so we get less dependent on those shrinking elements of that one graph that you showed, you know, and rely more on renewables. Yeah. But just turning it all off may not be very practical either. Because of some of the dependencies on the environments that you mentioned a little bit earlier in your talk.
Yeah.
So any last questions from the audience before we wrap up today? No, I think a happy crowd is or a silent crowd is always a happy crowd for these presentations. So I want to thank Majlinda again for a fantastic talk. I learned a lot, and I'm sure that others did as well. And so we'll be posting this to our website so that for those that weren't able to join us for the talk today, they'll be able to phone in. But I'd like to thank you all for attending. And again, thanks, Majlinda. It's a pleasure working with you, and thank you for sharing your expertise with us today.
Same. I can say the same. Thank you, Liz, for all your support.
Thank you. And if, again, just one more plug before we go, you know, for those who are just discovering us through YouTube, please feel free to visit our Women in Technology page at Mohawk College, www.mohawkcollege.ca/WiTT, if you're looking for other programming around the tech talks, so that you can learn about other emerging industry trends and a little bit more about how women are involved in the programs and the technologies that we have implemented. Have a great day, everyone.